The aim of this experiment was to observe how elements degrade when certain elements come into contact with each other. A particle is made up of neutrons, protons, and electrons. Neutrons and protons are in the nucleus, and electrons reside in the outer shell. Under certain conditions, the particle may transfer its electrons to a neighbor particle, thus giving a positive polarity to the particle and resulting in a degradation of the donor particle. This process is known as oxidation. On the other hand, the process of a particle receiving electrons is known as reduction and results in a negative polarity. The sum of these processes is known as ionization. Using these two polarities, we can obtain the potential difference and thus the degree of degradation. In order to achieve ionization conditions, the element made up by the oxidation particle must be placed in a certain solution, corresponding to an element that will have a compatible particle to the element. An electrode must be immersed in each element and connected by a salt bridge. The salt bridge will allow for the potential difference to be transferred between the solutions. The elements being tested in this experiment were copper, silver, iron, zinc, and tin. Potassium was used to make the salt bridge. Each element required its own solution for ionization, and the amount of solution required per liter of water was calculated using the atomic mass. Once the amount was determined, simple proportion was used to obtain the weight of the solution for 50 milliliters of water. The solution required for copper is copper sulfate, combined with 5 particles of H2O. The constituents are 1 atom of copper and sulfur each, 9 atoms of oxygen, and 10 atoms of hydrogen. This sums up to 12.477 grams per 50 milliliters. The solution required for iron is iron sulfate, combined with 5 particles for H2O. This requires 1 iron and sulfur atom each, 11 atoms of oxygen, and 1 atom of hydrogen. This sums up to 13.89 grams per 50 milliliters. The solution required for tin is tin chloride dihydrate, which is combined with 2 atoms of H2O. This requires 1 atom of tin, 2 atoms of chlorine, 4 atoms of hydrogen, and 2 atoms of oxygen. This sums up to 11.78 grams per 50 milliliters. The solution required for silver is silver nitrate. This requires 1 atom of silver, 1 atom of nitrogen, and 3 atoms of oxygen. This sums up to 8.49 grams per 50 milliliters. The solution required for zinc is zinc nitrate, combined with 6 atoms of H2O. This requires 1 zinc atom, 2 nitrogen atoms, 12 oxygen atoms, and 1 hydrogen atom. This sums up to 14.869 grams per 50 milliliters. The solution for potassium is potassium nitrate. This requires 1 potassium atom, 1 nitrogen atom, and 3 oxygen atoms. This sums up to 5.05 grams per 50 milliliters. The two elements being tested were each placed in a test tube filled with their respective solutions. The test tubes were placed in a beaker full of water, which had a controlled temperature. The two elements were connected to a voltmeter, and the salt bridge was placed connecting the test tubes. The stirring hot plate was used to keep the temperature and distribution constant. Copper was connected to silver, iron was connected to copper, zinc was connected to copper, zinc was connected to iron was connected to silver, tin was connected to copper. Since the result of copper and silver proved most theoretically accurate, it was used to study the effects of degradation by temperature change. The water in the beaker was cooled to 10 degrees Celsius and the voltage was recorded. The temperature was then increased and the voltage was recorded every 5 degrees Celsius. Here are the results obtained during this experiment.